All right, good morning and welcome to the final part of similar figures. All right, in doing that, we are actually looking more at scale drawings. So when you read a map, you'll always have a legend, but in there you'll also have a scale which tells you the distance on a map compared to the distance in real life. So, of course, in a map, it's going to be down to scale. It's going to be down to something that we can read and that we can figure out. But using the scale that they give you and using the distance on the map itself, you can figure out the actual distance between 2 points. Okay? So, we'll look at that here in just a minute, but we're also going to look at scale models. All right, when you build a model race car, a model airplane, or any type of model, it's going to be scaled down to size. All right, think about a Barbie doll. The actual Barbie doll, if she was in real life, is I think like over 8 feet tall or something, or over 7 feet tall. All right, if she was real life. All right, and so the size of the models are scaled down to the appropriate size for whatever they're used for. So if you're wanting to find a scale factor, which is what we're trying to do in the first problem, you take the length of the model over the length of the race car, and you find that the scale is 1/12. All right. Now, in order for it to be the correct size, you have to have the same scale factor for both the length and the width. All right. Otherwise, it's not scaled. It's not a true scale down to size or a true scale model, because if they do not have the same factor for both length and width here, then it's not true. All right. Then it just means that they've just made something smaller, but it's not to scale. All right. Now the width, you'll do the same exact thing. You take the width of the model over the width of the race car. 5.5 over 66, and when you reduce that fraction or divide 5.5 by 66, you get 1 over 12. So you found that both of these are 1/12, so therefore the scale factor is 1/12. All right, they would have to come out the same in order for it to be to scale. All right. Same way with this painting and photo. The only difference is they gave you the scale factor. That's not what we're looking for. If you have a scale factor and you have the two parts of, and you have at least 2 parts, you can find the missing pieces. Okay? So if the photo is 5.4 by 4, 5.4 centimeters by 4 centimeters, then you can find the actual measurements of the painting. All right? And you do that by finding the length. You take the scale factor 1 over 15. That means for every 1 centimeter, the painting would be 15 centimeters. And you set it up as 5.4 for the photo over the length. And now, if you took it 115 and you put L over 5.4, it's not going to give you the right answer. You have to do it by the scale. And the scale is the photo over the painting, 1 to 15. Okay? Because clearly a photo is smaller than a painting. All right? So you do it small over big. So then you cross multiply. 15 times 5.4 is going to give you 81 centimeters over 1, which is still 81 centimeters. So the length is 81 centimeters. The width, you do the same exact thing. The scale, once again, is still 1 to 15. And then you take 4, which is the width of the photo, over W, which is the width of the painting that we don't know. And then you cross multiply again. 15 times 4 over 1. All right? Because if you look on the paper, it's really 15 times 4 equals W. Well, 15 times 4 is 60 centimeters. So the painting is 81 centimeters by 60 centimeters. All right? Looking at the final problem and talking about that map that I was talking about, that on the map it'll tell you that like for every 3 centimeters it's 128 kilometers, and they might say for every 1 inch it's 100 miles, or for every 1 inch it's 100 kilometers. All right. So here they're telling me that for every 3 centimeters on the map, it's 128 kilometers. All right, so that's my scale, 3 over 128, small over big. All right, and then we set up our proportion because in the problem it says that we want to find the actual distance between 2 points, between these 2 cities. And that if the distance on the map is 10.5 centimeters, then what is the actual distance in real life? Well, you set it up as small over big, the distance on the map over the actual distance is equal to the distance on the map over real life. Okay? Or this is the scale. And then from there, you are going to end up setting up your proportion and then cross multiplying once again. 10.5 times 128 equal to 3 times x. So here I've got it already solved for you. X is equal to 128 times 10.5 divided by 3. Well, 128 times 10.5 is 1,344 over 3. And so when you take 1,344 divided by 3, you get 448 kilometers. So the actual distance between the 2 cities is 448 kilometers. All right. So go ahead and try the practice problems. Come in tomorrow with any questions that you might have, and we'll address them then. Thank you.